Hello.
Hello.
Well, good afternoon, everyone. And first, I want to welcome you. I'm so pleased that you are here, and I hope you are enjoying the conference and that you are learning a lot. So now, we're going to talk about eDNA and this project that I work in collaboration with SAR consultant and the University of Guelph at Hannah's lab. So for this project, we compared targeted qPCR detection and eDNA metabarcoding for the detection of Redside Dace in the Greater Toronto area. Redside Dace is an endangered species. It's very sensitive to any habitat disturbances. So any habitat loss or degradation due to urban development and agricultural is like the major threat for this species. Its distribution is overlapping with the Greater Toronto area, and as you could imagine, Toronto, this is the major urban area in all Canada. So this species has been very threatened by this great development in the city. So as we could see in the map on the right, at the top, on the right top, we could see some of the populations of Redside Dace pre-1970. What it distributed in red is what it was back then, the urban area. So more recently, in the early 2000s, we could see how the populations of Redside Dace in the red dots were more localized and decreased in some numbers. Under current legislation in Canada, environmental assessments are required before any development, like any urban or agricultural development in any land, to detect a species at risk, including Redside Dace. For environmental assessments, usually what is used are conventional methods like electrofishing or net patching, and as we know, electrofishing could be very detrimental to the species and also to the habitat. It's also constricted to seasonality and require a lot of permits for species at risk, to handle a species at risk, which could be problematic. And here is where environmental DNA represents a great opportunity, as we could see, an alternative and sensitive method to detect a species. But could we integrate this in environmental assessments? Well, the first goal of this study was to monitor the distribution of Redside Dace using parallel survey methods, including electrofishing or conventional method and environmental DNA, and assess the detection of the species, or if the species, Redside Dace, was present in an area of proposed development. And we also sample other sites with records of historical presence of the species and unknown sites. Our second goal was to compare two eDNA methods, qPCR as targeted detection for Redside Dace and also metabarcoding. So for our project, we sampled 10 sites that were relevant to the environmental assessment study. For these sites, we tested the presence of Redside Dace using 3 lines of evidence. First, electrofishing, and then eDNA with targeted detection, qPCR, and with metabarcoding. In addition, for environmental surveys, we include other 9 sites that we know where Redside Dace previously occupied, and also some sites where its distribution was unknown. Here is a map of some of the sites that we sample. We could see the green circles are the ones that are the 10 sites relevant to the environmental assessment, and in purplish pink are the 9 additional sites. So what we did is we sampled 19 sites in total across 3 different surveys. We took 2 filter samples at each site, and we include negative controls every day that we were out sampling. Our target volume was 5 liters, and we used 5 micron filters. So we took the samples back to the lab, and we processed them in an eDNA extraction in a dedicated space for this. And at extraction, we also include negative controls. Then we analyzed all the samples using a duplex qPCR reaction that will include a species-specific previously published assay for Redside Dace and with the inclusion of an internal positive control to measure inhibition. We analyzed every sample using 4 PCR replicates, and at this point we include positive and negative controls. So after the outcome of the IPC that suggested inhibition in all samples, we decided to include in our protocol a MAC-B cleanup protocol to clean them, to remove all the inhibitors, and then we reanalyze the samples using qPCR, but now with A replicates. And at this point, we also analyze the samples via metabarcoding, 1 replicate, and for metabarcoding we use 12S region minefish primers. For metabarcoding, it's important to highlight that the results were subject to a very extensive curation, geographical and ecological curation, to validate the detections of the species from metabarcoding. So what we found? Overall, we didn't detect Redside Dace at the 10 sites that were relevant for the environmental assessment study. We didn't detect the species via electrofishing, either with qPCR or metabarcoding. So we have 3 lines of evidence of the absence of the species or the absence of the DNA at these sites. But although we cannot confirm that the species is not fully there because we cannot sample all the water or all the region, we could assume that most likely it wasn't there at the time that when we sample. But another important outcome of our study was that eDNA detected Redside Dace at 4 sites. One site that was previously known to have records of Redside Dace, but also 3 sites of non-occupancy. We detected Redside Dace via qPCR at 4 sites, but with metabarcoding we only detected species at 2 sites. So if we dive a little bit deeper into the qPCR detections, we can see that we have great variability. So we have 2 samples per site, and the rate of detection changed across samples within the site, across visits, and between all the sites. We have one site with 100% detection probability, but we have other sites where we have very low detection rate. And if we compare the results before and after the cleanup, after removing the inhibitors, we could also see that in some cases, the inhibitor removal didn't change the results. In other cases, improved the results, so we have more detections after the cleanup. But what is more interesting to me is that one of the sites, for example, site 16, the detection rate decreased after the cleanup, which is what usually we are not expecting. Now, comparing the results between metabarcoding and qPCR, as I mentioned, we detected the species with qPCR at 4 sites, but metabarcoding only at 2. One of the sites that had the higher detection rate via qPCR, which is site 15, and also in one of the replicates from site 16, which was the site that the detection rate with qPCR decreased after the inhibitor cleanup, which is also very interesting to me because in this case, for metabarcoding, we have the detection, increase the detection after the cleanup for inhibitors, but with qPCR, we lost detection. Now, comparing the results between electrofishing and eDNA metabarcoding, we detected 9 species of fish via electrofishing. From those 9 species, 7 of them were also detected via metabarcoding. One of the species we were not able to assign to a species level via metabarcoding, and only the taxonomic assignation was to genus. And for the species the stonecat, we only found that species via electrofishing at one site, and unfortunately, the yield of DNA extraction was the lowest one. We have very bad quality of extractions at that site, and we believe that that's the reason why we didn't detect the species via metabarcoding. Also, via metabarcoding, we detected a total of 44 taxa, across all of sites and all of visits. But this doesn't mean that all those species were there at the time of sampling, and our results from metabarcoding were subject to an extensive geographic and ecological curation to verify the detections. So overall conclusion, Redside Dace was not detected in any of the sites that were relevant to the environmental assessments, and these detections, well, it was not detected via electrofishing or any of the two lines of evidence with eDNA. But Redside Dace was detected via eDNA at 4 sites. One site with historical records of the species, but more important and interesting to us is the 3 sites with non-occupancy of the species. That means the conservation efforts could focus to those sites. Also, we learned that PCI inhibition is a real problem, especially for qPCR, and we need to learn better how to deal with PCR inhibition. But also, the outcome of this project, really the question is, metabarcoding also sensitive to PCR inhibition, and to which degree? Because that is something that has not been really explored in the literature as much as the effect of PCR inhibition with qPCR. From our project, we learned that targeted qPCR was more sensitive and time effective to detect Redside Dace inner site compared with eDNA metabarcoding. So this could be a good outcome, like if your project only wants to know if Redside Dace is there or not, maybe qPCR is the answer. But we have to consider all the other information that we could get from eDNA metabarcoding. For example, in our study, we detected 3 important invasive species of concern across the sites, some of the sites that we sampled. And this kind of information is what cannot be retrieved from qPCR. So as we are learning, we will be agreed that eDNA doesn't want to replace conventional methods and electrofishing, and instead is a complement. We also think that qPCR and metabarcoding are 2 techniques that are complementary, and we cannot just separate them or choose one or the other. It will depend on the question of our study, and in most cases, they could work together to answer important ecological questions. So finally, I want to acknowledge all the team who was involved in this project, my colleagues from the University of Guelph and SAR, in collaboration with Lateral Developments, and this project was also funded by MITA's Elevate Fellowship. And I will be happy to take questions.